Yo, yo. Can anyone hear me? Go ahead and give me a thumbs up if you guys can hear me. What's up, everyone? Can y'all hear me? Give me a thumbs up if you guys can hear me. I'm just making sure everything's working on my end. Again, thumbs up if you can hear me. We're going to do some integrals today. I think I have a good amount of fun integrals, I think. Let's see, I have 9. But I think we're going to do this a little different. I'm going to give you 2 different integrals, and then we're going to choose which one the entire chat wants to solve. And then we'll do that together, and then we'll probably do the one that I already had, and then we'll go to another 2. Again, if you guys can hear me, give me a thumbs up. Can anyone hear me? Let's see if you guys could even see me on camera. There we go. Okay, it looks like everything's showing up soon. All right. Let me go ahead and pull up my Blackboard now then, since we are ready to get started. No, you shouldn't be nervous about Calc 2. It's fun. What are you currently taking right now? I'm assuming you're in pre-calc going into Calc 2. Oh, if you already finished Calc 1, then I'm assuming by now you should have done what? Like you finish off like the disk method. I believe that's where you finished off. If it's the same book that I'm thinking of, it's like chapter 6.2, maybe to chapter 7. But yeah, I think you're going to be fine. Calc 2, you're going to see it's going to be a review of things that you learned in Calc 1. And then now it's just going to be a new it's going to be new material. So different integration methods. But yeah, you should have a good time. Oh, you finished off Riemann sums. Okay. I still think, given that you finished that, I think you should be fine. Okay? These are actually types of problems that you will see in Calc 2. Honestly, these are more recreational. I think a lot of teachers might give these problems to you, but for the most part, only because they want to give you a challenge. I don't see them necessarily giving you this in higher level math or like during the tests and stuff. But again, these are just fun. In my opinion, one of my favorite types of things to do. Sometimes it's just fun to play around with integrals here. But anyway, all right, let's go ahead and get started. I'm going to go ahead and write the first integral that I want to do, and that's going to be a partial fraction problem. Let me just go ahead and write it out. I wanted to start off with this one because I think this is one of the easier ones to do. Actually, no, let's go ahead and I put the wrong one. My bad, guys. All right, here we go. What up, math nerd? Yo, you here to keep me in check again? I don't think I'll make that many mistakes today. I'm hoping that I don't, but it is my first day back after a long weekend. Hope you're doing well. All right, so here we go. I have this integral here. What is the method that I should use? Let me know in the chat what you guys think. And I don't think there is going to be multiple answers. I think for the most part, there is going to be one correct answer for the method that we should use. Amelia said trig sub. That's interesting. I would definitely try that next. Let's hold off on that, okay? Complete the square, user 1365 said. Okay, you know what? That's not what I was thinking, but let's just go ahead and do that, all right? This is the whole point of this live, is just to kind of have fun with it. All right, let's go ahead and complete the square. Complete the square and then trig sub. Lucas said partial fractions, I'm assuming AB, but you know what? We're going to go with completing the square and then trig sub because that's what the chat started saying in the beginning. And by the way, I think completing the square is so dumb. I absolutely hate it, but I'm still going to do it. So let's see. Every time we complete the square, we're going to take that b value, divide it by 2, and square it. So 4 divided by 2 is 2, squared is 4. And don't worry, if I make any mistakes, Math Nerd is on the chat here. He is going to make sure that I stay on track. Okay, I added my 4, and I still have the 5. And this is the important thing about completing the square, is that when we introduce that new value, I have to make sure I subtract the 4 to the other side. Yo, you guys really wanted to come. Okay, I like this. So now that we're going to complete the square, that x squared plus 4x plus 4 is going to become x plus 2 squared, and then plus 5 minus 4 is going to be a plus 1. Oh, not bad. Okay. Oh, Amelia, I see you're changing your mind. It's going to be some fraction decomposition. All right. Gemini, just stick around. This is all fun. No, not Python or MATLAB. All right, guys, I get so distracted with the chat. Stop doing that to me. Okay, so here we go. I think this is correct. X squared plus 4x plus 4. If we complete the square, it turns into this value that I have. And then, so let's see. I forgot it was username, and then Amelia said trig sub. If I'm going to do trig sub, this looks like an arctan problem. So what should my u value be if I'm going to use an arctan problem? Yes, Chipotle, it's going to be a trig identity. Okay, I need to choose a u value because I can't just integrate this. But again, this looks very much like a value or a trig identity that we know. Yes, thank you, Chipotle. X plus 2 du is equal to dx. Someone said, Amanda, can you teach me how to do tax? We can do that soon, maybe on Friday, okay? Today we're going to stick to integrals, but I'll keep that in mind. Okay, so u is equal to x plus 2, du is equal to dx, and now we can go ahead and rewrite this integral as integral of 1 over that u squared that I had, and then plus 1. And of course, I have my du. This is a beautiful integral. This is the trig identity. This is a very useful integral that we see so many times in calculus. Who was it in the very beginning that was talking about Calc 2? User 338. This is exactly what you're going to use when it comes to Calc 2. This is a type of stuff you're going to see. So yes, Sheg said it's going to be an arctan problem, and it absolutely is. So if you recall, the arctan problem looks like this. 1 over a arctan of u of a. This is typically going to be our response. Now, because we know our u was the u that we have, the a value is just going to be 1. This is just going to equal to 1 over, whoops, not 1 over, arctan of u plus c. But then don't forget that we have to plug in the u that we originally had. So this is going to be arctan of x plus 2 plus c. And if someone wanted to check their answer, they can go ahead and take the derivative of it and then just see if it equals the original integral that we had. All right, guys, so this was just a warm-up. I think I'm ready. So as I mentioned in the very beginning, I'm going to give two integrals. I'm going to say integral 1 and integral 2, and you guys are going to decide which ones you want to use. Okay, here we go. So this is my first integral. Looks very similar to the one that we had, but I'm going to tell you right now that I think is a little different. Okay, so let's try this one. 5x plus 19 over, let's do x squared plus 4x plus 3. Okay, this is integral number 1. And then let's go ahead and put integral number 2 on here. Which one should we do? Should we do x cubed over root 1 plus 2x squared dx? Okay, so go ahead and let me know in the chat. Integral number 1, or should we do integral number 2? So number 1 looks very similar to what we did in the very beginning. Integral 2 is somewhat easy. What do you guys think? Go ahead and let me know in the chat. Which one do you prefer, integral number 1 or integral number 2? Okay, so Shake said number 2. Color difference in number 1. Ooh, so here's the thing. If we do one of them first, we're going to do the other one after. So it's all about like how much time you guys have, which one you want to see be done. Okay, but it looks like color difference in number 1, number 2. Okay, so it's a tiebreaker right now. I need someone else to let me know what integral we should do, 1 or 2. Let me know in the chat. And if no one says it, then I'll just decide for us. What should we do? All right. Okay. It's another tiebreaker. Okay, one more. I swear to God. One more, because it's 1, 2, 1, 2. And then MPN 11 said we're going to do 2. So we're going to do integral number 2, and then we'll talk about integral number 1. I have a really fun one, guys, that I'm going to do. And I think I'm going to leave it at the very end. Hopefully we have enough time to do it. It all depends on how many people vote for it. But anyway, okay, so we're going to go ahead and do integral number 2. And again, I'll come back to integral number 1. But let's go ahead and do that. All right, guys, so what do you think with this integral? What should we do? Is it a trig sub? Is it a U sub? Is it an integration by parts? Is it a Feynman technique? I'm just kidding. We're not talking about Feynman technique today. Okay, so someone said U sub. Is that a foot as in a foot soldier? I'm curious because I just see U sub, but I think you're right. Let's run with that U sub. We should definitely do a U sub. So our U should be that bottom value. 1 plus 2x squared dx. Here's the thing, guys. Whenever you're trying to decide what your u should be, it's typically going to be the one that's maybe a little more complicated, but always give it a try. Even if you feel like you messed up, you're going to see, okay, you only did a couple of lines of work, and you erase it and then choose another value. Okay, so someone said write the demo as an exponent. But anyway, let's go ahead and do u sub. So then our du is going to be 4x dx. Now, I typically like to move the 4x to the other side so that our problem looks like this. So for our du over 4x is equal to dx. Okay, so now let's go ahead and plug that into our integral. And we're going to have integral of x cubed over root u times du over 4x. Okay, you're going to see that it's still a little tricky there because we still have values in terms of x and we still have values in terms of u, but we obviously want everything in terms of u. But let's go ahead and simplify some stuff. There's an x cubed on top and there's still an x on the bottom, so we can go ahead and cancel out the x and make the x cubed a square. And then because this 4 is in the denominator, I'm going to go ahead and pull that out. So I see 1/4 integral of x squared over root u du. Now, I'm very confident that we are on the right track, but can someone tell me what I should do instead? Trig sub might be an option, JN sub, but you know what? We ran with u sub here. Okay, so again, we have values in terms of x, and then we still have the u. So how can we be clever about this and continue solving it? I guarantee that we're on the right track. Oh, Harry, nice to see you again. Santos, okay, integrate. Yep, that's what we're trying to do. But let's see, guys. This is the part where whenever we're stuck with something like this and we have an x and we still have u. Right, here we go. The foot, said the math major, and so did Chipotle. We are going to look at the u is equal to 1 plus 2x squared. I put a dx there. I don't know why I did that. I'm sorry. Okay, Mather, where you at, bro? You got to correct me. Okay, so the reason why we're going to look at this is because we're going to be able to isolate the x squared. Check this out. Move the 1 to the other side. Divide everything by 2. And then we have u minus 1 over 2 is equal to x squared. I saw some people had posted that already on the chat. That's awesome. And that's exactly what we're going to do. All right? So now we're going to go ahead and plug that into our integral. So we have 1/4 integral of, remember, that x squared was that u minus 1 over 2 that we found. So we have u minus 1 over 2 over root u du. Okay, let's go ahead and rewrite this just a tiny bit. I have the 2 that's being divided. That's technically like a 1/2. So I'm going to go ahead and pull that outside into the integral. So I have 1/8 integral of u minus 1. And then I already know that we're going to have to divide by the denominator. It's going to become u to the 1/2. I rewrote that root as u to the 1/2. Because now I can rewrite this integral as u over u to the 1/2 minus 1 over u to the 1/2 du. All right, looks like we need to make some space on the blackboard here. Let's go ahead and make this a little smaller. How was everyone's weekend, by the way? I feel like everyone had a 4-day week. I had a 4-day weekend. Some people had a 3-day weekend. Yeah, I had a good weekend, but how was everyone else's? Had some good food. Let me know. First day of spring semester? Interesting. Oh, so that means you had finals like just recently. Okay, right on. Well, I hope you enjoy. I mean, how cool that you're enjoying your spring semester doing integrals. That's what's up. Okay, guys, so let's go ahead and simplify this. I have 1/8 integral. Now, that first fraction, u over u to the 1/2, is going to be u to the power of 1/2. How did I do that? Keep in mind, u to the power of u to the 1/2 is the same thing as u to the 1 over u to the 1/2. And using the property of exponents, we are just subtracting the exponent. So this is 1 minus 1/2. All right? And then so we have minus u to the negative 1/2, because that second fraction, all I did was just bring that to the other side, or brought it up on top and I made it negative. And so now we have 1/8 times u to the 3/2 divided by 3/2 minus u to the 1/2 divided by 1/2. And we still have the plus c. I think, knowing some linear algebra will probably help you. User 890785, yes. Okay, so let's just rewrite this. I still have the 1/8 on the outside. I'll take care of that at the end. And that 3/2 on the bottom becomes a 2/3 altogether, u to the 3/2, and then minus 2, u to the 1/2, and then we still have the plus c. All right, and now we're technically done. So two things that I'm going to do. I'm going to go ahead and distribute the 1/2 to both terms, and I'm going to go ahead and plug in that 1 plus x squared back in for the u. Okay, so here's going to be my answer. I'm going to have 1/12 1 plus 2x squared to the power of 3/2 minus 4 and then 1 plus 2x squared to the power of 1/2 plus c. I know it's a little tricky. I guess I should have just done a different marker there, or a different color, so that we can know exactly what that answer is. All right, guys. That was integral number 2. I don't know how long we've been going live. Not sure. But anyway, don't forget to like this live. Follow me for more math problems. On Thursday, we are going to do a fun explanation of how implicit differentiation can be solved using partial derivatives. So if you haven't learned about partial derivatives, we're going to do a couple problems about that. Then we're going to talk about implicit differentiation, and we're going to see how it relates to that other stuff. Okay. Math nerd, 1/8 times 2 is equal to 1/4. Yeah, you're absolutely right. I don't know why I put 4. I guess in my head I was just thinking of the 4. Yep. Okay. So that 4 that I'm circling should be a 1/4, guys. So I should erase it, and it should be a 1/4. Thank you. See, math nerd, we're dogs, bro. The Riemann Zeta, I don't know if we're down for that right now. Maybe for another time. But we could do that possibly Friday, okay? I want to stick to just integration practice today. All right. So here we go. Let's see. Actually, we're going to do like a knockout level. So this was the integral number 1 that people were voting for. Okay, let me add another one, and I'm just going to entice you guys. Let's see if you want to do a problem like this, okay? Let's go ahead and do x squared plus 6x plus 31 all over x squared minus 19x minus 30. Nice, Joshua. Welcome, welcome. All right, guys, 2 different integrals. The first one was integral number 1 that we didn't want to do, or that a lot of people did not vote for, and then we have a new integral. So I don't know. What do you guys think? Should we do integral number 1 or integral number 2? Harry says they don't know how to solve either, and that's okay, because this is all part of the plan. This is all part of having fun. Okay? Okay, Joe said integral number 1. I'm trying to see who else in the chat wants to do integral number 1 or perhaps integral number 2. Let me know in the chat which one you prefer to be seen. Okay. Integration by parts. 1. All right. It looks like 1. 1 is going to win because that is what a lot of people are voting for. So let me go ahead and erase number 2. Oh, guys, and I have such a fun one. I think we'll have time to do some more, but no, we definitely will. And I have a fun integral that I found online that I was kind of stumped for a second, but I thought it was actually really fun to do. But anyway, here we go, guys. We are going to go ahead and do this particular problem. Now, what do we think? I want to hear in the chat, okay? Or I want to read in the chat what people want to do. So Joe said is number 1 partial fractions. I think it could be a partial fraction problem. There's a possibility. I don't know, maybe. Yeah, don't do your stats homework. Fuck that. Partial fractions, simplify. Someone said U sub, okay? You know, it's interesting about this is that maybe you can do a U sub or partial fractions, but try to see if we use partial fractions, can we even factor that? Okay, no clue, no clue. Integration by parts. Oh, I don't even know that. Maybe a Feynman technique, but we'll do that later. Not today. Not today, but maybe some other time, I promise. Factor x plus 1, x plus 3. Oh, yeah, I can't even think about whether or not that was factoring. Okay, so it seems like we could do a partial fractions. Should we just try that? Do a partial fractions? Someone says synthetic division. So Danny, look at that. If you try to use synthetic division, the top degree is 1, the bottom is 2. It's going to be very difficult to divide that. Don't forget that when we want to use long division, the degree of the top has to either be the same or larger than the degree of the bottom. Okay, so someone said... Okay, so let's go ahead and do partial fractions. Okay, let's go ahead and do that. So let's see. If I don't know why I put a 1 there. So, okay, if I simplify this. So someone said, I believe it was Joe, that said the bottom can factor out into x plus 1 times x plus 3. That seems to be true because 1 and 3 multiply to 3, and then those add up to 4. Okay, cool. And the reason why we're doing this is because we're able to factor it, so we're going to create a partial fraction. So this is what we want, guys. This should equal to something a over x plus 1 plus b over x plus 3. Okay, I think someone already said, Brady had already mentioned what that a value is going to be, but we're going to double check if that's true. Okay, so how are we going to do this? On the right side, if we were to add these together, we're really just getting common denominators. So this will be a times x plus 3 plus b times x plus 1. And that whole thing is equal to x plus 1 times x plus 3. And don't forget that this has to equal the left side. I'm not going to worry about the integral part just yet, because first you just want to split this up. Okay, we can completely forget about the denominator because they're the same. Austin said cover-up method. Someone had mentioned this. I don't know if you were on the chat last week, but I have to look that up. But I 100% agree that the cover-up method would work. Someone was super confident that that is a method that's used. So I'll definitely want to try that next time. Okay. Psycho, yes, this is the a plus b thingy. Okay, guys. So now that we completely disregarded the bottom because they're both the same, 5x plus 9 is equal to a times x plus 3. And then plus b times x plus 1. Now, Austin, correct me if I'm wrong, but is this the cover-up method? In this case, this is where we want to plug in something, for example, like x is equal to negative 3, so that when you plug it into this first parentheses, it completely cancels out. I'm not sure if that's going to be correct. I'm not sure if that's what the cover-up method is, but that's a method that a lot of people use. Oh, okay, Joe's saying yup, or maybe yup to something else. Awesome. Okay, so let's go ahead and use that. Yeah, that's the way I learned it in high school, but a lot of my students now, they're taught differently. So I kind of run it with their method, but I like this. Let's go ahead and do the cover-up method. So the cover-up method is just plugging in something to the parentheses so that, or plugging in something to each parenthesis so that it cancels out. So again, if I plugged in negative 3 into this parentheses, that will completely cancel out that value because negative 3 plus 3 is 0. Okay. But I have to make sure I plug in negative 3 to all the other values. So I have 5 times negative 3 plus 9 is equal to, remember we said that first term is 0, plus b times negative 3 plus 1. Okay, so negative 15 plus 9 is equal to b times negative 2. All right, so negative 15 plus 9. Everyone correct me if I'm wrong if I get this incorrect, but I think that's going to be negative 6 is equal to b times negative 2. And then we can divide the negative 2 to the other side and get that 3 is equal to b. Okay, let's go ahead and make this smaller. If I made mistakes, let me know. Don't worry. I believe Math Nerd's still on the chat here. He would definitely correct me if I'm wrong. Guys, I'm the king of typos. I make these mistakes all the time. I just like these stuff or these integrals. Okay, cool. So b was equal to negative 3. If we continue with the cover-up method, we use this equation and we make x is equal to negative 1 because, again, if you plug in negative 1 to that other value, that will cancel out. So then we have 15 times negative 1 plus 9 is equal to a times negative 1 plus 3 plus, and then 0. That covers up. Okay, so negative 15. I don't know why that shouldn't be a negative 15. I'm sorry, guys. That should just be a 5. So negative 5 plus 9 is equal to 2a. So let's see. Negative 5 plus 9 is 4, and that's equal to 2a. So that tells us that 2 is equal to a. All right, so we did the partial fractions. Let's go ahead and make this even smaller. And then find our integral. Okay, so remember, this integral, 5x plus 9 over x plus 1x plus 3, was going to equal to the integral of the a value, which was 2, over x plus 1. I think someone had found that in the very beginning. I think it was Austin. I have to look back in the chat. But they said that it was going to be negative or 2, and then plus the b value was going to be 3 over x plus 3 dx. All right, guys. The reason why we do this is because the integral on the right side is very easy. Who can tell me in the chat how we will solve this? There's a simple integration method. I believe Harry will definitely know this. Let me know in the chat what you guys think should be my last few steps. Natural log absolute value, Danny. Yes, 100% agree. It's going to be a natural log type problem. So this should integrate very easily. We just have a 2 on the outside and a natural log of absolute value of x plus 1. Who leaves the absolute value? Who sometimes does not write it? I don't think some teachers care, but I know it's the right thing to do. But some people always forget it. Let me know if you guys are guilty of that. Okay, someone said, shouldn't the b be a negative 3? Let me just double check my work here. No, I think it's still I think it should be a positive 3. I think the b value should still be a positive 3. Thrice, thank you. Thank you. Okay, it is 3. Perfect. Guys, you guys are more than welcome to pull out a piece of paper and write these things down because, again, these are super fun to do together. All right, so let's see. I have, how much time we got? Man, we got plenty of time, guys. No. I don't know the username of that, but the only numbers you should know is your daily prayers. This stuff isn't needed. I have to respectfully disagree. I mean, come on. Who doesn't want to learn some integrals? Who doesn't want to learn these methods? This is just fun. So this is such good exercise for your brain. Okay, so let's try. Guys, I'm here for the people. You guys decide what integral we should do, but here is a fun one. And then maybe we can do natural log of x squared plus 4 dx. All right. Labs, divergence theorem problem. Maybe on Friday, okay? Today, I'm sticking to integration practice. That's for Tuesday. Thursday, I'm going to do partial fractions and implicit differentiation. And Friday, maybe I can do something like this. So Friday is off trail. I mean, who knows what we do? So if for 10 minutes we're doing one thing, for the other one we're doing something else, then we'll do that. All right, so let's see. I'm seeing integral number 1. Thank you, Harry. They said they want to do integral number 1, but I'm curious what everyone else wants to do. And when we're doing that, don't forget to like the live video, follow me, because, guys, we have fun every Tuesday, Thursday, and Friday. Rate of change problem on Friday. Okay. Yeah, that will be really fun. Maybe I could just pull some up from the book and just get them. Hey, that's all good, but listen, man, some people's religion is math. It's all good. Okay, so it looks like 1, I see 1, 2. I only see 1, 2, so we're going to do 1, and then we're going to go to integral number 2. Don't worry, I won't leave you guys behind. All right? Okay, so we're going to do integral number 1, and then differential equations. Maybe I could do that on Friday, all right? So integral number 1, what do you guys think? What should we do? What method should we do? Is it U sub? Is it trig sub? Is it partial fractions? Is it math is totally a religion. This is my religion. Yo, man, let's just do whatever we want. All good. U sub. Some people say U sub. Okay, if you guys are saying U sub, go ahead and tell me what you think the U value should be. Okay, someone's saying partial fractions. Pedal Bear, yes. You know what, Space Cowboy? I think I did a video on not particularly this, but it was one of the problems that I have in one of my books, and I did a full video on that. And there is necessarily, you could say there is an identity, but I think it's going to be long. Okay, someone said SOAP. Let's go. Okay, partial fractions. So again, U sub. You're gonna see if you tried U sub, it just wouldn't work. Okay, and I'm going to tell you real quick. So Harry said, okay, let's go ahead and try U sub, and I'm just going to show you why that's not going to work real quick, but it is going to be partial fractions. Math here is all about just making the mistakes, kind of messing around with these things and seeing what's going to work. Okay, guys, check this out. If I did, that's going to be 3x squared. If I make the U value, that entire thing on the bottom, that will make my du 3x squared. And then du over 3x squared is equal to dx. And look at the issue that we have. 1 over u times du over 3x squared. Now we can do that, but then it just gets messy. And you could totally try to mess around with the u that you originally had, but it's going to be so hard. Okay? So someone said SOAP and partial fraction decomposition, and that's exactly what it's going to be. So again, always try a method. That doesn't work, go back to the drawing board. So let's go ahead and redo this, and it is going to be a partial fraction decomposition, obviously. Okay, so this is going to be SOAP. Okay. It's not useless against unless you can use it. Well, I mean, just once you get good at it, guys, this is just fun. I mean, why do we do a lot of things? You know, this is just, it's all good time. Quotient and product rule. I will do that. Be ready for that Thursday. Partial fractions and implicit differentiation. So quotient rule and product rule, that will be there. All right. So if I simplify this, I am going to use the difference or the sum of cubes in this case. So I use this formula. A cubed plus B cubed is equal to A plus B over A squared minus AB plus B squared, where A was X and then your B was 1. Some people call this SOAP because it's same, opposite, always positive. All right. Listen, peace and love, man. Come on, let's not do this religion stuff, man. Come on, we're having fun with math. I don't want to ban you. Okay. So check that out. I did partial fraction I did difference of cubes. All right. So what do you think, guys? I think now it's time to use some partial fractions. Let's go ahead and do that now. Okay, A over X plus 1 plus B over X squared minus, whoops. Okay, let's see if you guys caught my mistake here. Okay, did I make a mistake there? I did my partial fractions. I mean, I just split those two values up. There we go. So people said that the top of the quadratic should be a bx plus c. That is the problem. Because on the bottom you have a quadratic, so that means that on the top you need to have 1 degree less. So it should be a bx plus c. Thank you, chat. Thank you, chat. All right. Yes, here we go. All right, so as I mentioned, I'm not even going to bother too much into writing like the partial fraction stuff here in terms of like setting it equal to the 1 over x plus 3 plus 1. Remember, all we care about is about the numerator. So the way we're going to do that is we're going to do a times x squared minus x plus 1 plus x plus 1 times bx plus c. And that should just equal to the numerator on the right side. Okay. Harry, you got to practice with partial fractions, okay? Go online and just hammer down with those things. Super fun, okay? And extremely useful. Okay, guys, so here we go. We have our partial fractions, or we multiplied everything out, and now we have to show all that work because that left side is equal to 1. That's a lot, okay? So let's go ahead and distribute the a on that first parentheses, and then on that second parentheses, I unfortunately are going to have to FOIL. Tony, I'm not sure if you can use matrices for these. Or, I don't know if Austin, if people are on the chat, could I do the cover-up method here? Should I try it? I don't know if that's gonna help. But let's just see what cancels out. Okay. All right, guys, I'm sorry. Hold on. I am gonna go on a ban real quick. I have to. You know what? No. There's no room for hate on here, man. I am so sorry to do this. But, bro, we're just having a good time here. I just want to make sure I'm banning the correct person. I'm so sorry. Guys, peace and love. There's no room for hate, man. I know we were talking about religion. It's all fun and games, but we just can't be hating on each other. Sorry, guys. Anyway, this is a place for math. This is all a place to have fun. Religion, I don't care who you are. We're having fun doing math problems, and that's exactly what we're going to do. Okay, so back to doing that. We're going to go ahead and multiply the a to all terms. So we're going to do ax squared minus ax plus a plus, actually, let me continue doing this in green so you guys can keep track of this. So ax squared minus ax plus a plus, and then I have bx squared plus cx plus bx plus c is equal to 1. All right. Okay, but here's the thing. So sometimes the cover method is not going to work out, but check this out. All right, we're going to group everything. Look at these, the ax squared and the bx squared. Okay, that's going to be a plus b times x squared. Okay, because that all has a like term, so I combine that. Now check this out. I have the negative ax, I have the cx, and I have the bx. Okay, I can combine those and put plus negative a plus b plus c, and then all times x plus, and then I got the last terms, the a and the c. So that's going to be a plus c is equal to 1. All right. And the reason why we're doing this is because now, well, look at this. This has to equal the right side. So the only thing we care about is a plus c needs to be equal to 1. Okay? That's this, what I'm about to highlight in green. What do you guys think? Let me highlight this. What do you guys think these values, the coefficient for the x should equal to? I highlighted that in yellow. What do you guys think that should equal to? Zach said 0. Yes, absolutely right. So, Aiden, I'll definitely talk about partial fractions a little further later in the future, but the reason being is because this needs to equal the right side. And if you look at the right side, it's only equal to 1. So everything that has a variable needs to equal to 0. So a plus b plus c is equal to 0. And then I got the last value here, which I'll highlight in blue, the a plus b. If you look at the right side, that has no x squared, so that has to be a plus b has to be equal to 0. And, you know, when you have problems like this, let me go ahead and make this smaller. When you have problems like this, we are just going to have to make sure, you know, you got to practice your partial fractions, but you also got to practice your systems of equations. Okay, so check this out. Again, I know this was difficult, but as you can tell, the initial integral was pretty tough, but it gets more complicated. Or no, the initial integral will look really easy, but it's pretty complicated. My bad. Turn that around. Okay, so look at what I'm going to do here. On the first value that I have that c is equal to 1 minus a. So I'm going to go ahead and plug that into the second equation here. So I have negative a plus b plus 1 minus a is equal to 0. And then I still have that third equation, a plus b is equal to 0. But that's okay because look at that second equation. Okay, I'm just worried about the two equations here. If I combine the a's, it becomes negative 2a plus b plus 1 is equal to 0, and then a plus b is equal to 0. Let me just actually move the 1 to the other side in that first equation, and that's negative 2a plus b is equal to negative 1, and then a plus b is equal to 0. Okay. Corey, are you talking to me? All right. So again, remember, as I mentioned, you have to know your system. So for the first or the second equation, I'm going to go ahead and multiply by negative 1 so that I have negative 2a plus b is equal to negative 1, and then negative a minus b is equal to 0. Guys, now we can just use some simple, the b's are going to cancel out using systems here. So this is negative 2a is equal to negative 1. So a is equal to 1/2. This is just a. But all good, because now we're going to be able to find b, and because we know a, we're going to find c. You're going to see how that's going to work in a second. Let me just make this smaller. Ooh, wee. Okay. Negative 3a. You're absolutely right. Yes, you're absolutely right. Fuzzy hairs. Yes, absolutely right. It's going to be negative 3a. Let me change that. So in that last problem, when I combine the negative 2a and the negative a, it should be negative 3a is equal to negative 1. So then up here on the left side, a should equal to 1/3. Thank you, guys. Thank you. Okay. So now that we know that a is equal to 1/3, let's go ahead and go back to any one of these problems. Remember that a plus b is equal to 0. So then that means that 1/3 plus b is equal to 0. So b is equal to negative 1/3. So we have a is 1/3, b is equal to negative 1/3. And then now, if you recall, c is equal to 1 minus a. So now we can go ahead and plug in the a value, 1 minus 1/3, and that's going to be 2/3. Okay. Hope I didn't make any mistakes there, but now I'm going to rewrite my integral. Okay. I'm going to make this small. Maybe too thick. Okay. So isn't it negative? It was 2b. No, the b's canceled out. There was a lot of work here, but guys, I do have. This is all on a replay, so I'm going to post this on my YouTube, so you guys are welcome to look back at this. And if I messed up, Elba, if you see that I messed up, let me know. If anyone in the chat agrees with Elba, let me know if I messed up there. But I believe it was negative 3b. Okay, guys. So, as you recall, the integral 1 over x cubed plus 1 dx was equal to the integral of, a over x plus 1 plus bx plus c over x squared minus x plus 1 dx. We're not even done yet, guys. So if you recall, a was equal to 1/3, so this is the integral of 1/3 over x plus 3 plus our b value was negative 1/3 x plus our c value, which is going to be 2/3, all over x squared minus x plus 1 dx. Okay. So let's talk about the first integral here. There's a 1/3 on the top, so we can go ahead and put that on the outside. So we have 1/3 integral of 1 over x plus 1 dx. At that point, I'm pretty sure you guys can solve this one. This is one of the easier ones. And then now we have the other one plus. Let's see. There's a negative 1/3. There's a 2/3. So how about I pull out, maybe I can just pull out like a 1/3 from it. So this becomes negative x plus 2 over x squared plus x plus 1 dx. Okay, so I think that first integral, the 1 over x plus 1, that's pretty simple. That is a natural log integral. We can easily solve that. So let's just go ahead and write that now. So this is 1/3 natural log of x plus 1 plus 1/3 integral of negative x plus 2 over x squared plus x plus 1 dx. Okay. Let's talk about that second integral. What do you guys think I should do? This is the integral you all wanted to do. Integral of x cubed plus 1 dx. Okay, so if you guys are just coming in the chat, if you guys are a little late, this is the integral that we're trying to solve. Whoops, it was an x cubed. This is x cubed plus 1 dx. Okay, someone said factor. Someone said complete the square. All right. So, Harry, if you try to factor that, just try to even factor. That was one of the factors of the cubes when we did difference of sum of cubes, and that can factor out. But you should always try. Again, if you have ideas, always try them out. Okay? I don't think USUB would work either. All right? There's definitely a lot of things that won't work on here. So someone said complete the square. Someone said quotient rule. We can't take the derivative of this, unfortunately. Okay? So this is one of the ones, again, super annoying. Change the sign for the x in the denominator. I'm definitely going to probably do that. So someone said arctangent. All right, I'm about to show you guys. I'm about to show you it's negative x, not x in the denominator. Oh, yes, you're absolutely right. Monkey. Yes, I see where you're at. Let me go ahead and change that. Guys, again, thank you so much. You see how much work we're doing? I'm bound to miss a sign. So, Monkey, who was it? Monkey, just Monkey said, oh, what's up, Monkey? So, Monkey had said that I had a negative x on here, and that should be a negative x on there too. And that's true because it should be the SOAP. Thank you, thank you, thank you. Okay, don't worry, Chico. This is recorded. I post it on my YouTube every single time that we go live. Tuesdays are integration. Thursdays are going to be partial fractions and implicit differentiation. Friday is off trail, man. We are going to do whatever you guys want. Okay, so let me just kind of show you guys how we're going to solve this, all right? I'm going to lead you guys to the promised land. This integral on the bottom here, if I were to use USUB on that, x squared minus x plus 1, and I take the integral, I'm going to be left with 2x minus 1. Okay? So just think about that. I'm going to be left with 2x minus 1. So here's what I'm going to do, okay? I'm going to kind of blow this up a little bit because I know that it's getting quite crazy. But I'm just going to rewrite this, and you're going to see why I'm doing this, okay? First, what I'm going to do is I still have the 1/3 on here. I'm going to multiply everything by, let's do a -2 on the top. And I have an x plus 2. But because I multiplied a -2 on the top, I need to make sure I also divide it by a -2. So let me just rewrite that now. Okay, you're going to see why I'm doing this. Okay, so part of this whole thing, making it smaller. Oh my gosh, I just want to get done with this problem. But you're going to see why we're even doing this, okay? So this -2 on the bottom is going to come outside. Okay, maybe I can do a couple things. Okay, so let's do 1/3 natural log of x plus 1. That was the first integral there. So this is going to be -1/6. Again, the reason why I got that is because I pulled out the -2 that's on the outside. And now what we're going to do is let's go ahead and this is going to become -2x plus 4 over x squared minus x plus 1 dx. Okay. Did I miss a sign? -4, yes. So someone said, Harry, it's going to be -4. Let me just go ahead and set that. Thank you, Harry. So let me just change that up right here. This should be -4 over x squared minus x plus 1. And now we have the dx. Okay. And again, the reason why I'm doing this is because, again, if you think about it, u is equal to x squared minus x plus 1. Well, du is equal to 2x minus 1. So that's kind of what I want. Okay. Look at the numerator. This is a -4. If I add a 5, you're going to see why I'm doing this. And I'm going to subtract the 5 as well. Let me just rewrite this. We're getting close, guys. Just making sure I didn't mess anything up, or I didn't mess anything up. So check this out. I have negative 2x. If I combine the negative 4 and the plus 5, that becomes a plus 1. I guess I'm just going to do plus. Let me just erase it, actually. There we go. So again, if I combine the negative 4 and the 5, that becomes a plus 1. And then this is going to be a minus 1. And you're going to, I'll mention that in a second, why that's even there. So on the bottom, I have x squared minus x. Whoops. X squared minus x plus 1. Minus x plus 1 dx. All right. We're almost done. Let me just make this a little smaller because you're going to see why I'm doing this. Okay. Whoops. Not that big or not that wide. Okay, let me just move it. Okay, look, now I'm going to separate that second integral into two integrals. I have negative 1/6 integral of negative 2x plus 1 all over x squared minus x plus 1, and then minus 1 over x squared plus x plus 1 dx. Okay, and this is why I'm doing this. That first integral, my u is equal to x squared minus x, du is equal to 2x minus 1 dx. So if I divide that 2x minus 1 to the other side, I get du over 2x minus 1 is equal to dx. Now that's going to help me because that's going to be u substitution. That last integral, we're definitely going to integrate it using integration by parts. And I think I have to make this even smaller. It never ends. Okay, I promise after this, we won't do one this long, but you guys chose it. So now we have 1/3 natural log of x plus 1, and now we have negative 1/6 integral of negative 2x plus 1 over u times du over 2x minus 1. Now, the top here cancels out, and the bottom cancels out. One is just the negative of the other. And then on the other one, I still have minus integral of 1 over x squared plus 1, or minus 1, I'm sorry, plus 1 dx. Okay. Now that second integral is going to turn into this. Negative or positive 1/6 natural log of the u value, which is x squared minus x plus 1. And then minus, I still have 1/6 integral, or I guess I should do a plus since it was a minus there, 1 over x squared minus x plus 1 dx. And that last integral, we're just going to integrate it by using completing the square, and it's going to be a trig sub. Okay, so I know this is long. We have an option. Should we go on to the next problem, or should I just finish this one up? I know it was long, but what do you guys think? I have two fun ones I think are a good time, so I definitely want to make sure I touch on them. I have like 20 minutes left until we go to our next section. Okay, so Fuzzy Ball said finish it. All right, we're in this together. We're in this together. So we got the very last section, and I think someone's like, I messed up in like a negative sign or something, so obviously there's going to be something wrong. If you guys see this on my YouTube, go ahead and just let me know in the comments. But if that's the case, my bad. As you can see, that's a lot of freaking work. Okay. I still have that first value, 1/3 x plus 1 plus 1/6 natural log of x squared minus x plus 1. Okay, so let's finish this one up, guys. Let's go ahead and complete the square. And it's going to be 1 over x squared minus x. And because I'm completing the square, this becomes plus 1/2. And then we still have the plus 1. And because I introduced the 1/2, we're going to do a minus 1/2. And we still have the dx. Okay. I'm just going to focus on the last integral. Okay, we'll write our answer at the very end. But I'm just going to focus on that one. This is going to be 1/6 integral of 1 over x minus, it shouldn't be a 1/2, I'm sorry, it should be a 1/4. Doing so much work here, guys. So it should be x minus 1/2 squared, and then plus 3/4 dx. Okay, and that last integral is just going to be an arcsine, or an arctangent, I'm sorry. So I think we're going to make this small for the last time. We're going to finish up the problem, and then we will be done. So here we go. Okay, so I have 1/3 natural log of x plus 1 plus 1/6 natural log of x squared minus x plus 1. And then this is going to be plus 1/6 times 1 over root 3 over 2 arctan of x minus 1/2 over root 3 over 2, and then the whole thing plus c. All right, guys, this is what happens when you have a sum of cubes or a difference of cubes. If it was a difference of cubes, it will be even more difficult, but that's something for another day. Okay, this is I believe this is very similar to problem 66 in my integral book that I did a video on. So if you guys want to check out my YouTube channel on that problem, it gives you like kind of like a walkthrough on that. Okay, so let's see. I got like a good 15 minutes left on a problem like this. Let's go ahead and do, you guys decide. I have integral number 1. Don't vote yet, because one might be more intriguing than the other. Or integral number 2. Whoops. And this goes on and on. All right, guys. What do we think? Integral number 1, integral number 2. Fuzzy Ball said number 2, number 2. Thomas, ain't no way. Okay, so number oh, it seems like no one wants to do number 1. Okay, so maybe that could be up for you guys. Write it down somewhere. Maybe take a screenshot of this so you could do number 1 on your own. Guarantee is probably an easier one. Okay, so I'm seeing 1, 1, 2. God, what do you guys think? I feel like, should I just leave 2 up to you guys, or should I just complete it? Okay, all right. So okay, let's do number 2. And I guarantee that it's going to be much easier than you think. All right? All right, let's go ahead and do this. This will be the final problem for today, and then we'll pick it back up on Thursday when we do some partial fractions and implicit differentiation. Okay, so we're going to do this integral here. All right, let me just go ahead and rewrite it. Or actually, I can just leave it on here, and we can talk about what methods do you guys think we should do? Is there something in particular you guys think we can do to solve this? Let me know in the chat if you guys have an idea of it. Okay. Let me start off with a little, I would say a little hint. All right, here we go. Let's go ahead and rewrite these roots. Okay, let me just actually erase it if anything. I'm just going to rewrite these roots. I'm going to do x, 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 x. I think that's enough. Okay, and don't forget, because these were all roots, we're technically taking them to the power of 1/2. So I'm just making sure I have all the powers and I have all the powers. Okay? Maybe by looking at this, it could be a little easier for you guys, or it makes a little more sense. All right, how do we solve this? Let's go ahead and start multiplying or distributing the 1/2 to that very first x. And then the only thing that we can really do is distribute it to that 1/2 that's right next to it on the left. Okay. So how does this become? Or what does this turn to? X to the 1/2 times, and then I have x, 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 and it goes on forever, to the power of 1/2, to the power of 1/2. And then now, the last power, it's no longer going to be to the power of 1/2. What do you guys think that's going to be? What is going to be that last power that I have? Don't forget, that's where I distributed that 1/2 to the other 1/2. Any idea of what this value is going to be? Let me know in the chat. Okay, Harry said 1. Maybe it could be something else. Not necessarily a 1, because remember, we don't add the exponent here. Here, we have to actually multiply the exponent, okay? So what that's going to become, it's actually going to become a 1/4. Okay, because remember, 0.25, thank you, Jack. So someone said closer to 0. So again, remember, the property of exponents for the first one, when we multiply the 1/2 to the x that's way on the other side, we just multiply the power to the power. Okay, so it was just 1 times 1/2, which is 1/2. And then that second time when we distributed that 1/2 to the other 1/2, you're multiplying that power, okay? So now let's go ahead and continue. Let's take this 1/4 and multiply it to the x in this parentheses. And at the same time, we're going to multiply it to that 1/2 that's right next to it, okay? Someone said a Taylor series. Maybe, perhaps. So now what do we have? We have x to the power of 1/2 times x to the 1/4, let me make this a little easier or better looking, times x, 1/2, and then what is that last power that I have? So what happens when I multiply the 1/4 times the 1/2? What would that become? That's going to become a 1/8. All right, let's continue again. Maybe two more steps. We're going to distribute the 1/8 to that x that's at the end of the parentheses, and we're going to distribute the 1/8 to that 1/2. So what does this become? X to the 1/2 times x to the 1/4. Wait, I realized that just my parentheses are off here. It should have looked like this. My bad. Okay, so this is going to be x to the 1/8 times x dot dot dot, and then that last power when I multiply the 1/8 to the 1/2 is going to be 1/16. So let's look at what's going on. If I continue this pattern, it will be x to the 1/2 times x to the 1/4 times x to the 1/8 times x to the times x to the 1/16. And if I continue that pattern, it'll be 1/32 dot 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 all the way forever. Okay, it's not going to be 0, but you're going to see what's going to happen here. So as you can see, right now I turn this into just bases of x with a power. What do we do to the powers whenever we have these things being multiplied together and they have the same base? We're just going to add them. So this is going to be x to the power of 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32, on and on and on. I think someone kind of already hinted at what the answer is going to be, but I'll talk about that real quick. Okay, so now let's just make this a little smaller. I promise you it's not as hard as the other one, okay? So if you notice that pattern, it's 1/2 plus 1/4 plus 1/8 plus 1/6. This is what we call a geometric sequence, where the first term is 1/2. Let me make this actually better. It's a geometric, or not a geometric sequence, it's going to be a geometric series. So I can rewrite this as summation from k, or I'll do n is equal to 1, where 1/2 is the first term, and it's being multiplied by 1/2 to the n minus 1 dx. Okay, now I kind of see that some people maybe already posted the answer, but this geometric series is an infinite series, and this is equal to a1 over 1 minus r, where a1 is the first term and r is the common difference, or the common ratio. So in this case, that entire thing is going to equal to x to the power of, the first term is 1/2 over 1 minus the common ratio, which is 1/2. Let's simplify this a little further. X to the 1/2 over 1/2, which, what do you know, turns into x to the power of 1 dx. And one of the easiest integration methods that we use here is the power rule. So this just becomes x squared over 2 plus c. There we go. How fun was that, huh? All right. And I think that unfortunately is going to do it for today. What do you guys think? Difficult? Easy? I think the sum of cubes was probably the hardest one. Okay, but listen, I am gonna see you guys on Thursday. All right, on Thursday we're gonna do introduction of some partial fractions. I'm gonna talk about how that relates to implicit differentiation. We're definitely going to do some implicit differentiation problems. But again, you guys are more than welcome to see this replay. I'm going to post it on my YouTube. Please subscribe. If you guys like what I do, follow me on here on TikTok, follow me on Instagram, follow me on YouTube. Check out the different books that I have online. But yeah, I'm going to see you guys on Thursday, 3 p.m., same time. All right. Thomas, I've done some stupid hard girls, but that one you just had to. Yes, that's all you had to do to remember series. And to be honest, I didn't see that trick, but I saw someone do it online, and I thought it was pretty fascinating. Yep. All right, guys. Well, anyway, this is where I leave you. I hope that you guys have a great, wonderful end of your Tuesday. Have a great Wednesday, and then I'm gonna see you guys. When would it be? On Thursday, same time. Okay. All right, everyone. Take it easy, have fun, be safe, and until the next one.